I primarily do research in ionized gas physics. The application of that is electric propulsion. What electric propulsion really is taking electricity from solar cells, from solar energy, using that to either heat propellant, in this case some type of a gas like xenon, or accelerate charged particles. We take this gas, we ionize it by using electron discharges, which means we shoot electrons into it, we make charged particles, and then we accelerate those charged particles. And the electricity is what gives most of the energy, most of the force that's used in the electric propulsion to produce thrust. It enables us to go to places faster and cheaper than any other chemical propulsion system would be able to. Electric propulsion is used right now every single day for direct TV and satellite radio communication satellites in Earth orbit. The sun and the moon tend to want to pull these satellites out of position, and we use electric thrusters to push them back into position. Asteroid capture is really challenging because you don't want to bring back a very small rock. You want to bring back a very large rock. We're talking about almost 1 million pounds. And in order to return it to the Earth, you have to put a lot of energy into that transfer to bring it back into the right orbit. With an electric propulsion system and modern solar arrays that give you about 50 kilowatts of power, you can do it with electric thrusters. Capturing an asteroid is really kind of exciting. There are actually a couple of companies out there that are talking about mining asteroids. They would primarily mine them for special metals like gold or platinum, things that are very, very expensive. But from NASA's point of view, the real idea of mining an asteroid or using an asteroid is to use those resources in space. And the resources you might have are there's plenty of iron and nickel and components that you would use for fabricating structures. But even more important than that there's water in asteroids. And you can either use that water to support astronaut life, or you can use that water to shield astronauts from radiation. It takes a lot of money to launch mass into space. If it's already out there, then we can use it as is, and it saves us all the effort of trying to take it there. This is going to demonstrate we can move around a 7-meter, 10-meter diameter asteroid. But if we can do that, if we learn how to do that, then maybe in the future we can actually then figure out how to deflect a 100-meter diameter asteroid. This is an application for planetary protection. What happens if that big asteroid is coming to the Earth? Can we deflect it? Can we do something to stop that so we save our population rather than lose our population? And that will then be something really beneficial for the world. It's very important that you find something that you like to do. So in a lot of times you go and you'll become a physics major or an engineering major or some discipline of engineering and get into that coursework. And sometimes that's exciting to you and you stay in it, and sometimes it's not. And so don't ever become discouraged. Get out there and try it. If you're not enjoying what you're working on now, try a different field in engineering and science and research and industry, and you'll find something that's really exciting for you, and that will make it motivating for you to keep doing your work. I don't have a job. I play every day in the lab. I love it.